Good morning. So because we're always so short of time, I wanted to make a video for making a histogram and making a time series plot for this particular data. So this is the stuff that we had in class the other day, and because we're constantly short on time, I feel like I shortchange you guys on getting some sort of more detailed explanation about how to do these types of things and work the calculator. So this will let you watch this at your own pace. So here's the data, and if you want to pause the video here so that you can enter that into your calculator. So let's see, let's get this set up. There we go. All right, so you've got the data hopefully now in your calculator, and let's get this all good, like so. There we go. All right, so I should have my data in here. So I've got stat, edit, and let's see. So right here, those are the presidential ages in order, and I've already entered them all in. And remember, you just go stat, edit, and then just start typing in the numbers. Now you'll notice over in this column, I've got all of the numbers from 1 through 45. You can see that they're paired up here with the ages of the presidents, right? So there's the 45th president, and there's 45 that's paired up with. So I'm going to show you how to make that sequence of numbers again. So if we quit out of here, so always start from this main screen, otherwise you'll accidentally start typing things into these cells, and the calculator doesn't like that. So quit out. And now I'm going to make a sequence of numbers. So in order to do that, you go to List, Ops, and down to number 5, Sequence. So the first, it says the expression. So this is where you type in the equation that you want. So like if I wanted to go by 2's, then I would write 2x. But I want to go by 1's, so this is just going to be x. Right, so in the x button is right here, right? The x, t, theta, n button. So this variable is x. Or the expression is x, the variable is x. We're going to start from 1, and we're going to end at 70. And what that's doing is plugging in 1, 2, 3, etc., all the way up to 70. Although I didn't really want to end at 70, did I? I wanted to end at 45. Ignore the step, just go to paste, hit enter. And so now I've got sequence x, comma, 1, comma, 45. Now if you have an older calculator, this is exactly what you would have to type in, because you wouldn't have that screen that I just had. You would just go sequence, and it opens up this parenthesis, and then you just type in the variable, the expression, the variable, where you want to start and where you want to stop. Okay? So then I'm going to store this. So you hit the STO button, lower left-hand corner right there. You're going to store it in a list. So you just pick the list that you want. Well, I had list 4 open, so I can just go second function. And see the little L4 right there? So second function number 4, hit enter. So now it's created all those numbers, and you'll notice if I go back to stat, edit, there they are right there in list 4. So the question that I asked was, does it look like these presidents, as time passes, are getting older or getting younger? Does it appear that the age at inauguration of the presidents is relatively consistent, or do they get younger as time passes, or do they tend to get older as time passes? So that's my question. So I want to look at the data. So I'm going to make a time series plot. So this is George Washington, the first president. This is John Adams, the second president. This is Thomas Jefferson, the third president. So if I'm looking for an association between time and how old the presidents are at inauguration, then I want my horizontal axis to be, ideally it would be the dates at which they became president, but I don't have that information, but I do have the order in which they became president. So I'll have number 1 get paired with Washington, number 2 get paired with Adams, number 3 get paired with Jefferson, etc. So this is going to be my x-axis, or my independent axis, and this is going to be my dependent axis. So all I have to do now is I go to stat plot, upper left-hand corner, not the y equals button, but see how it's in blue? So I'm going to go hit the blue key, second function key. So I go second function stat plot. And now notice all of these plots are turned off. You want to make sure that they're off And to do that, go all the way down to plots off, hit enter, and hit enter again. If you don't remember to do that, sometimes you'll have multiple plots turned on, pulling from lists that no longer exist, and that'll make a mess. So go to plot number 1, it's turned off, hit enter on it. Notice it's highlighted on off, but it's flashing on. So I'll hit enter on, and then I'm just going to scroll down, and I want a time series plot, so that's going to be a scatter plot. That's that very first one. So I'm going to go to scatter plot. And then I have to decide which list is going to be my X list and which list is going to be my Y list. Well, my X list, that's a horizontal axis. I've got that information stored in list 4. And I've got the presidential ages, which is going to be the dependent axis. I've got that stored in list 3, so second function number 3. And now I'm ready to go. But my window's probably not sized correctly, so I'm going to have to adjust the window. So notice my window on X is just going from -10 to +10, right? So I want it to go from 1 through 45. So I'll actually start at 0, just so that I'm smaller than the smallest X value. And I'll go up to 46, just so that I'm bigger than the biggest X value. And the scale is just, what do you want the tick marks to represent? Do you want to go by 1s or by 2s? I'll just go by 1s. The Y value here, this is the smallest Y value. Well, what's the youngest president? Well, that's Teddy Roosevelt, and he was 42. So I'm going to start from smaller than the smallest, younger than the youngest president. So I'll start from 40. And then the oldest president was Donald Trump, so we're going to go up to 70, but I'll go a little bit bigger. I'll go to 75, just so that I can see the top of the graph. And now if I go graph, there they are. Can you see that? So now notice I've got something else graphed right here. So I'm going to go to my Y equals, whoops, let's see, Y equals. I've got something else being graphed here, some mess. So let's, whoops, let's get rid of that, clear it, and now I can go back to graph. And so now the question that I asked was, does it look like the presidents are getting older or younger? Or does it look like there is no trend in the presidential ages at inauguration? So what we can do now is we can run some numbers on this, but do we see a very clear trend? And the answer is no, not really. It kind of looked like the presidents got younger for a while, and then they started to get maybe a little bit older, but we can be a little bit more precise by that, in that if we look at what's called a regression line, or the line of best fit. So what I'm going to do is I'm going to go Stat, arrow over to Calc, and I'm going to come down here to linreg. That just means linear regression, ax plus b. So it's going to be y equals mx plus b. So it's the equation of the line that fits the data the best. I'm not going to go into a lot of detail on that. When we get to, I believe, chapter 10 or 11, then we're going to talk about this in a lot more detail. But for now, I'm just going to go linreg, boom. And then I have to, again, tell it the X list and the Y list. So the X list was list 4. The Y list was list 3. And leave the frequency list alone. Go down to store regeq. So I'm going to store the regression equation in Y1 where we normally graph lines. So in order to do that, I hit the vars button. I arrow over to yvars, hit enter on function, and I want to store it as Y1. Notice these are just the Y values that are here at the Y equals tab. So I'm going to store it here as Y1. So that way I don't have to write the equation down and then type it in myself. The calculator will just type it in for me. So then we calculate it. And now I've got some information. Well, this is a little bit odd. I've got, let's see, I've got an A value of 1 and a B value of 0. That doesn't make any sense. Let's try that again. Stat, calc, linreg, list, oh, I did list 4 and list 4. It was list 4 and list 3. There we go. And now I have to go vars, yvars, function, y1, and calculate it. That's much better. So this is the slope of the regression line. Notice that slope is very, very close to 0, which means it's not changing very much. It's very slightly negative. And we'll talk again a lot about that in chapter 10 or 11. Here, this is telling me the y-intercept, which is probably pretty darn close to the average presidential age. So we're going to go, and in fact, let's find out. Let's go stat, calc, 1var stats on list 3 for me, because that's where I've got it stored. You probably have it stored in list 1 or list 2. And so this is the presidential ages. The average presidential age is 54.97, which is 55 years. And remember, my regression line had roughly 55 years as the y-intercept. And so when I go graph, there's the regression line. Notice it has a very slight downward trend, but not enough for us to really say anything about the presidential ages. Something I do notice is it looks like there's a lot more scatter around the line out here than there is in here. And notice these guys in here are all younger than the average, which is kind of interesting. So there was a large group of time in here where the presidents tended to be younger than the 55 years average. And then over here, we've got random scatter around the line. And up here, we've got presidents that tended to be older than the average. So does there appear to be a very clear trend in presidential ages? The answer appears to be no. And we can talk more about this again in Chapter 10.